Here's page 2 of the study guide. Problem number 5, we see some pretty extensive answers here. So before we do any work, let's try and figure out what we have to do. We see which of the following is true about the curve x squared minus xy plus y squared is equal to 3 at the point 2, 1. And then we see dy dx beginning for all 5 of these. So obviously we're going to have to find the derivative, right? So we're seeing either exists or does not exist. And then we see tangent line, no tangent line, or tangent line is horizontal or vertical. So horizontal tangent lines obviously mean that the derivative dy dx is equal to 0, and vertical means that the derivative does not exist. So let's find our derivative. Let's plug in 2, 1 and then see what happens. Okay, as far as finding the derivative, once again we have this xy, so we're going to have a product rule. Now we're going to have to be careful here because of the minus sign. So you can either think of this as, the opposite of x times y, and do a product between the opposite of x and y, or you can have minus and then in parentheses do the product of x times y using the product rule, and then distribute the minus sign. But just be careful with that minus sign. Okay, so here we go. So x squared is going to derive to 2x. I'm going to think of this as the opposite of x times y. So when I derive the opposite of x, I get negative 1. I'm just going to write the minus sign, and then I'll just put in a 1 even though I don't have to. And now I keep the y. So derive the opposite of x and then keep the y, right? Plus, now I'm going to keep the opposite of x and I'm going to derive y, which is dy dx. And then I have plus 2y for the derivative of y squared, and that also needs a dy dx. And then over on the right side of the equation I see equals 3, so that's going to become 0. Okay, so just to write this all over again, we see we have 2x minus y minus x dy dx plus 2y dy dx is equal to 0. So let's get our non-dy dx terms over to the other side, and we can do that by adding y and subtracting 2x. Right, so we now have the opposite of x, dy dx, plus 2y dy dx is equal to y minus 2x. Okay, we can factor the dy dx out. So we have the opposite of x plus 2y is equal to y minus 2x. And by division, dy dx is y minus 2x over the opposite of x plus 2y. Okay, now we're interested in the point 2, 1. So I'm going to replace x with 2. So that means I'm going to have a minus 4 and a negative 2. I'm going to replace y with 1. So that means I'm going to have a 1 and a 2. All right, so what happens? In the numerator, I'm looking at a 3. In the denominator, I'm looking at 0. Okay, so we see 0 in the denominator. All right, when we're dividing by 0, that means our slope, remember dy dx is our slope. Our slope is trying to divide by 0. That is a vertical tangent line. So dy dx does not exist at 2, 1. All right, we're divided by 0. That does not exist. And the tangent line at that point is vertical. There's our answer for D. Okay, now we move to a table of values for number 6. The table above gives the values of the differentiable functions f and g and of their derivatives, f prime and g prime, at certain values of x. P is g of f of x, and we want the slope of the curve at a point. All right, so we want a derivative. All right, we are being asked about p prime. Well, p is a composite function, which means chain rule. So we derive the outer, g derives to g prime. We're going to take the derivative of g with respect to f. F is the inner function, right? G is the outer. Right? So now, after we take the derivative of the outer with respect to the inner, we multiply by the derivative of the inner. So there's p prime. We're interested when x is negative 1, so we want p prime of negative 1. So that's g prime of f of negative 1 times f prime of negative 1. All right, so f of negative 1, here's f, here's negative 1, f of negative 1 is 1. So this is equal to g prime of 1 times f prime of negative 1. g prime of 1, there's 1, is a half, and f prime of negative 1, here's negative 1, f prime is 3. So we have half of 3, or 1.5. So our answer is B. And then 7 is a lot like number 1, except it's now tangent, and we have to evaluate at a point. All right, so this is where our trig chart knowledge is going to come into play. So f of x is equal to the tangent of 2x. We want f prime of x, because we need that before we can find f prime of pi over 6. So what's going on? Well, tangent derives to secant squared. And then so we derive the outer, this is our outer, this is our inner, and with respect to the inner, and then we multiply by the derivative of the inner, which is 2. All right, so f prime of x is 2 secant squared of 2x. All right, now we're interested in f prime of pi over 6. So that is 2 times the secant squared of twice pi over 6. 2 pi over 6 simplifies to pi over 3. So actually I'm going to write it this way, 2, and then I'm going to have secant of pi over 3, but that is being squared. Okay, secant of pi over 3. Well, secant is the reciprocal of cosine. So cosine of pi over 3, all right, I don't know if we remember that or not. If we go through our cosine column, cosine starts, we got 0, and then pi over 6, pi over 4, pi over 3. Cosine starts at 1, and then drops to root 3 over 2, and then root 2 over 2, and then we see 1/2. So the cosine of pi over 3 is 1/2. So therefore, the secant of pi over 3 is the reciprocal of the cosine of pi over 3, or 1 over 1/2. 1/2 goes into 1 twice. So this is 2 times 2 squared, or 2 times 4, or 8. So our answer is E. That's page 2, page 3 coming up.